So a 2x2 system is two equations with two variables. There are three options for solutions for this type of system. We can have one solution, meaning that those two lines, linear equations, would cross twice. Second, we could have no solution. In this case, the variables cancel and the remaining statement is false. We could also have infinitely many solutions, in which case the variables cancel and the remaining statement is true, like 3 equals 3. If we have this situation, we have to solve an equation for y, and you'll see that in just a second. So we're going to look at these two equations first. And the first thing I'm going to do is rewrite the top one. I wrote it the same, right? And then I'm going to rewrite the second one in the same format so everything lines up. So I just moved that 4 to the other side. Now I'm ready to add them. And when I do, everything cancels and I'm left with 0 equals 0. That is a true statement, so the system has infinitely many solutions. So now that I know it has infinitely many solutions, I have to solve one of those original equations for y, because those solutions must follow that situation. So I'm going to choose the top one to solve for y. And so that's the equation they must follow. Because when it says infinitely many, that doesn't mean that just any old solution will work, right? It has to be the one where you can pick any x you want, and then you plug it into that equation to find the y. Let's look at the next one. Notice that everything's already lined up, right? The x's, the y's, and the -3's. So I'm going to look at the y's there. Look at it like I'm solving it, so we'll get rid of the y's. So I'm ready to add. And when I do that, I get 0 equals -6. And that statement is false, so the system has no solution. The other option is that you work it out and it works out just fine like it has before. And in that case, it would be the system has a unique solution and you would enter it.